Hi there, this is a video about triangle congruence. Today we're going to be talking about the congruence theorems of ASA and AAS. The first theorem I want to talk about is ASA, which is an acronym for angle, side, angle. So let's say that we have two triangles here. Now I'm going to name this triangle here on the left triangle A, B, C. And the one on the right, I'm going to name it X, Y, Z. All right, and here's what I know. If I'm talking about angle, side, angle, what I want to do is show that in one triangle, angle A is congruent to angle X, and that the segment length of AB is congruent to the segment length of XY. And lastly, I want to be given that angle B is congruent to angle Y. Now, as I look at this triangle here, what I notice is that I have an angle, two angles that are congruent to two corresponding angles over here, and an included side length here for AB and here for XY. So as I look at this, I want to write this as angle, side, angle. Angle, side, angle. And this is all the information that I would need to show that these two triangles are congruent. So if I make a congruency statement here and I say that triangle ACB is congruent to triangle XZY. And notice how when I name this ACB, that I use the corresponding sides XZY in order. So if I order it ACB, I have to order this as XZY. All right, so let's write out a definition for angle, side, angle. And so by definition, this says if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. And that's what this says. I have two angles and the included side, okay? To two angles are congruent to two angles in the included side here, then these triangles are congruent by angle, side, angle. All right, now let's look at angle, angle, side. All right, and so what I have here, I'm going to name this one triangle A, B, C, and we'll call this one X, Y, and Z. All right, so what I want to do here is show you the concept of angle, angle, side. So if you're given an angle, let's say that angle A is congruent to angle X. All right, so angle A is congruent to angle X. Let's say that angle B is congruent to angle Y. So angle B is congruent to angle Y, and that you're given that the length of CB is congruent to YZ. So the length of CB is congruent to YZ. All right, so once you have these statements here, this is enough information to show that these triangles are congruent. All right, and what this shows is that you have an angle, and a side. All right, and that you have an angle, and a side. All right, and so as you move around, if those are the only pieces of information that you're given, then you can come in here and you can write out a congruency statement that says triangle ACB is congruent to triangle XZY. Now let's write out a definition for angle, angle, side. All right, so by definition, this states that if two angles and a non-included side of one triangle, so two angles and a not included side, so this side is not included in between these two angles, all right, is congruent to two angles and a non-included side of a second triangle, then these triangles are congruent. So this is all the information that you would need to conclude that these triangles are congruent. Let's look at a couple proofs. All right, so let's take a look at a proof here. What we're given is this picture here, and you're given that angle X is congruent to angle K, and that N is the midpoint of line segment XK. And given that information, we want to draw conclusions and arrive at the proof statement that triangle XML is congruent to KMP, okay? And so from here, what I want to do is walk you through the logic of what we're going to show here. All right. So the first things first, we're given that angle X is congruent to angle K. So I'm going to come in here and I'm going to mark that up, that these two angles are congruent. All right. The other piece of information we know is that M is the midpoint of XK. So if I come in here and I say that XM is going to be congruent to MK, because those two that's what a midpoint does, cut something in half. The other thing that I know is that this inside angle here, XML, is congruent to KMP. All right, and the reason why is because those are vertical angles. And what we see here is that you have an angle, a side, and an angle. You have an angle, a side, and an angle. And from this information, what you can now conclude is that these two triangles are congruent by angle-side-angle congruency theorem. So let's write out the statements and reasons of this proof. All right, so once we have our t-chart here and we have statements on the left side and reasons on the right side, I want to start writing out our given statements over here in our statements and provide that our reasons. All right, so I always write out my given statements. Those are the first things I write out. And the next thing I want to write out is our third statement. And it's what can I conclude from this information? Okay, so knowing that M is the midpoint of XK, what I can conclude is that the segment length of XM is congruent to the segment length of MK. So I'm going to write that XM is congruent to MK. All right, and the reason I know that is that's the definition of a midpoint, okay? That's what a midpoint does. It cuts something into two congruent parts, and we get those congruent parts, and we can say that those are congruent, all right? So that's what a midpoint does, all right? Now, the next thing that I can say is that angle XML, so statement 4, is that angle XML is congruent to angle, let's do KMP. All right, and the reason I can make that statement is because those are vertical angles. And so my last statement that I can make in statement 5 is the fact that these triangles are now congruent because I have angles that are congruent to each other, that's given to us, an included side, and then these other angles. All right, so what we can say now is that triangle XML is congruent to triangle KMP. All right, and the reason for that on step 5 is that we are using angle, side, angle to do that. All right, and that's all I have for this video. We'll see you soon. Thanks a lot. Bye.